Hello, welcome to Tuning Review. This episode is the 0th episode, so instead of reviewing a tuning, I'm going to introduce you to Xenharmony, which is basically any musical tuning that is not a typical Western tuning. This video assumes you already have some basic knowledge of tuning theory and typical Western music theory. So, let's start our Xenharmonic adventure with a thing called an Edo. So, what is an Edo? Well, the term Edo is an acronym which stands for equal divisions of the octave, or equally divided octave, depending on which word you prefer. I've heard the former, but I digress. So, what does that mean? Well, first, you probably know what an octave is, a 2-to-1 ratio between two different frequencies. An Edo is effectively a top-down way to construct that tuning. You take this octave interval and divide it into a certain amount of equal parts. The reason we divide an octave instead of dividing other intervals is that an octave is a really consonant interval, so when you play two notes an octave apart, they have a sort of octave-y cohesion, which makes the two notes sound very similar. This concept is known as octave equivalency. After we run out of notes, we simply repeat the same notes but one octave higher. Now, in typical Western music, we divide the octave into 12 parts. In Indonesian Khmer music, they divide it into 9 parts. Some African music divides it into 10, and other cultures around the world sometimes use different systems that aren't even Edos. As contrasted to Edos, just intonation, abbreviated as JI, is a bottom-up way of constructing tuning. Instead of stacking an octave on top of a root and then dividing it into equal parts, we take our root and stack pure intervals on top of it instead. And then we have it repeat at the octave, or maybe another interval depending on what just intonation tuning you're using. Typically, the intervals are ones from the harmonic series, because those are typically considered very constant. This creates a very pristine and perfect sound. However, just intonation isn't a unified system, and if you really want to, you can stack relatively imperfect intervals, or do a combination of both to get whichever sound you want. Another type of just intonation is neji, which is a compromise of both Edos and just intonation. Neji stands for near equal just intonation, which as the name implies is just intonation which approximates equal temperaments, also known as Edos. The way to construct these is to find a set of intervals which are very near to your target Edos intervals and put them together in a just intonation tuning. Now let's go back to our old system, Edo. Isn't the fact that we use an octave for that relatively arbitrary? I mean, it's not completely arbitrary, but let's just say that it is arbitrary. This leads to a group of systems known as EDX systems, where we replace the X with whatever interval we want to divide. The most famous one of these is Boland-Pierce, which is 13ED3-1, which can also be defined as 13EDT. T here standing for Tritave, which is another name attributed to the 3-to-1 ratio. In this tuning, we assume that octave equivalency is just something we're encultured to believe, and it rejects the idea for what's called the Tritave equivalency, which is effectively the same concept, but for the 3-to-1 ratio of the Tritave instead of the 2-to-1 ratio of the octave. This concept can create very weird and out there tunings, and music made in it sounds very interesting. Another interval you can divide is the fifth, creating EDFs, the most famous of which is the Carlos Alpha scale, aka 9EDF. Dividing the fifth this way can create rather clustered tunings, but also pretty exotic ones. Fifths are arguably the second most consonant interval behind the octave, and notes a fifth apart kind of have the same cohesion that octaves do, only a little bit less. This means that tunings are a little more grounded than EDTs, but it's still very exotic and fun to play with. So, what's the point of all this? Why divide the pitch space into something other than the quote-unquote normal 12 equal divisions of the octave? Well, there are many reasons. One is to approximate intervals that are not possible to play in 12 Edo, such as 7-4. But my favorite reason, though, is to create music that sounds very different from your average 12 Edo song. Working with Xenharmonic tunings is also a group process of discovery. As well, a lot of theory has already been done. Even some Edos are very unexplored, such as 18 Edo. It allows you to explore completely uncharted musical territory and discover something unique to play around with. Generally, music is meant to be open and to be a creative process, so why limit ourselves to the same old 12 tones? Anyways, this has been Zip Creator. Remember to dislike and unsubscribe.